Hi dear students, welcome to my channel. This is a continuation of gravitation. Okay. Today what we discuss, gravitational potential energy. What is that? You know the formula. mgh. G is acceleration due to gravity. H is height from the ground. Okay. Height from the ground means on the surface of the earth. Potential energy U I am calling mgh. This is earth surface. From the earth surface at height, this is some h height. One object is there. Here one object is there of the mass m, small m. The potential energy of this object at a height h from the surface of the earth, that is mgh. Okay. But the g, acceleration due to gravity, is not constant. If you are going away from the earth surface, the acceleration due to gravity keep on changing. How it changes? It will decrease. That already I explained. So what is the range of the height where the acceleration due to gravity approximately may not be varying? Acceleration due to gravity is not changing. So up to some height, this g, acceleration due to gravity, we will consider it is a constant. Okay. For example, you might have fly by aeroplane. What height aeroplane will fly? It is around 10 kilometer. Approximately from the surface of the earth, 10 kilometer height, this aeroplane will fly. Okay. So at the height of 10 kilometer from the surface of the earth, what is the acceleration due to gravity? First we will calculate. Then you will get some idea. Acceleration due to gravity on the surface of the earth, how much? That already you know. That is g is equal to 9.8 meter per second square. Now we will calculate what is the acceleration due to gravity at a height 10 kilometer above the surface of the earth. Then how to do that? We will do like this. You know the formula, g is equal to capital G, capital M E by r square. Here capital M E, that is the mass of the earth. This is acceleration due to gravity for our earth, for our planet. So you know this capital G is constant, mass of the earth is constant. Here r is the radius of the earth. From here to here. This is radius of the earth. Radius of the earth is around 6,400 kilometer. Okay. Now what we are going to do? We are going to find out what is the acceleration due to gravity at a height from here to here. Means total distance from center to this point, that is r plus h. R plus h. There we are going to calculate. So for that we will derive one formula. Okay. You know capital G, capital M is constant. I will take this r square this side. So G into r square is equal to capital G, capital M E. That is the mass of the earth. So this part is constant. So you can have a relation like this. G1 R1 square is equal to G2 R2 square. Here R1 square is distance at particular point. From the center of the earth to the distance. So I will take from here to here, radius of the earth only, R1. R2 from here to here I will take. So G2 चाहिए. So G2 is equal to R1 divided by R2 whole square into G1. G1 is acceleration due to gravity on the surface of the earth. I am taking. And R1 is radius of the earth. Now we will substitute R1 is how much? 6400 kilometer divided by R2 is how much? From here to here 6400, here to here 10 kilometer. 6410 kilometer whole square into G1. G1 is how much? That I am calling as a acceleration due to gravity on the surface of the earth. That is 9.8. How much you will get? You will get approximately 9.7 meter per second square. This is not significant change in acceleration due to gravity. It is approximately 1%, even less than 1% change in acceleration due to gravity. So we can assume that the acceleration due to gravity is constant over 10 kilometer height from the surface of the earth. Okay, then what about some other, like International Space Station? What is the height of the International Space Station from the surface of the earth? Do you know? Just Google it. Okay, I will tell you. That is around 400 kilometers from the surface of the earth. Certainly, the acceleration due to gravity at the height of 400 kilometers from the surface of the earth cannot be near to this value. Certainly, there will be a significant change in the acceleration due to gravity at International Space Station. That also we will calculate now. What is the value of acceleration due to gravity at International Space Station? Presently, Sunita Williams, she is there only. Now we will calculate. Okay. You know, International Space Station is, that is 400 kilometers above the surface of the earth. Same formula we will use now. That already I told now. G1 R1 square equal to G2 R2 square. Okay. Now G2 we want, that is R1 by R2 whole square into G1. G1 I am calling G. R1 is radius of earth 6400 kilometer divided by 6400 plus 400. So that is 6800 whole square into 9.8. You will get acceleration due to gravity approximately 8.7 meter per second square. Acceleration due to gravity at International Space Station, it is coming around 8.7 meter per second square. It is significant change in acceleration due to gravity. So the potential energy formula mgh we cannot use as a generalized formula. This formula can be used up to around 10 kilometer height from the surface of the earth. Okay, then which is the perfect formula we should use to calculate the gravitational potential energy? That part we will discuss. Okay, now this is clear, no? So International Space Station में कितना acceleration due to gravity आपको पता चल गया. Now potential energy concept, potential energy of the system. Here our system is earth and any object. I am standing on the earth, our satellite is moving, our aeroplane is flying. For that object and earth system, we are going to calculate the potential energy. So for that, we should go back to work kinetic energy theorem. Work kinetic energy theorem, that is, if you apply a force on an object, the work done by the force is equal to change in its kinetic energy. First we will calculate the kinetic energy, and next the energy conservation. the total mechanical energy conservation, that is kinetic energy plus potential energy, is constant. By using that phenomenon or principle, we will derive the generalized formula for gravitational potential energy. Okay? That work kinetic energy theorem, already I told, we know the general formula W is equal to F dot S. This is general formula. F is applied force, S is the displacement. In terms of integration, F dot ds, F is applied force, ds is the smallest displacement. Okay? Integration, it is like a summation. For over the small displacement with a force F, how much work done? That's just like W1, W2, W3. Suppose particle is moving from here to here by applying the force. From here to here, how much work done? W1. Here to here, W2, W3, W4. W1 plus W2 plus W3, it is summation. Summation only we are calling it as integration. Okay? Now, we will derive this work kinetic energy theorem. So work done equal to change in kinetic energy is told. So change in kinetic energy is nothing but final kinetic energy minus initial kinetic energy. K2 minus K1 equal to Fs, F into S. You assume the angle between force direction and displacement direction is 0. Cos 0 is 1. So F into S. F is equal to MA, that you know from Newton's second law. MA into S is S as it is right. MA into S. This is A is acceleration. Because of force you applied, the particle will accelerate. From kinematics equations, you know V square minus U square equal to 2AS. Then A equal to, you can write V square minus U square by 2S. We can substitute A here. Then work done equal to K2 minus K1 equal to M into A value ऐसा लिखता हूँ V square minus U square divided by 2S into S. S cancel. What you will get? 1 by 2. 1 by 2 M V square minus 1 by 2 M U square. This is final kinetic energy, this is the initial kinetic energy. So you got a relation for kinetic energy mv square. Why kinetic energy equal to half mv square? This is the answer. Okay. So now you got an idea. Kinetic energy, the formula is half mv square. Generalized formula. Then k equal to, I can write half into mv square. If anybody asks what is the formula for kinetic energy, half mv square, then how you got it, how you derived? So this is the solution. Okay. Now we will discuss what is the total energy conservation. Total energy of the system, total mechanical energy of the system is constant. What does it mean? Kinetic energy plus potential energy is constant. You see this? This is at some height from the ground. I am holding it, that's why it is here. Otherwise it will fall down. So it has some energy now, that is potential energy, because of position. It is not moving now with respect to me. So kinetic energy is 0. I will leave it now. What happens? Falling down means potential energy converting into kinetic energy. Here the total energy is only potential energy. In the somewhere here in the middle, somewhere it will have both the kinetic energy and potential energy. The sum of kinetic energy plus potential energy is constant every point. Here, 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 here. At every point that is constant. So you will get the relation between kinetic energy and potential energy. By using that information, we can derive the generalized formula for gravitational potential energy. That part we will discuss in the next class. Till then, bye bye. But don't forget to subscribe my channel and share this video and like this video and tap the bell icon to get the notification for further uploads of my videos. Bye bye once again. Tada.